Okay, today's lesson is going to be on writing and balancing chemical equations. A chemical reaction equation is just basically a reaction recipe, just like a cookie recipe would be involving a cookie mix plus some eggs plus some oil to give us cookies. A chemical reaction would be a reaction recipe would give us compound A plus compound B plus compound C yields compound D. And in the case of a chemical equation, the reactants are the substances that are present before the reaction is done. And the products are substances present after the reaction is done. We separate the products from the reactants with a reaction arrow. And we read this as yields or reacts to produce. So reactants, yields, products. If there are multiple reactants or multiple products, they are separated with a plus sign. So up here is like we have reactant A plus reactant B plus reactant C yields product D. And that's basically the simplicity of it. There's nothing more complicated than that, although we have to make sure that when we write a chemical equation, a proper chemical equation, we have the right recipe with it. So we need to do what we call balancing an equation. And we'll get to that in a second. But first, let's get an example of a chemical equation and products and reactants. Okay, so here I'm asking you the question of what are the reactants and the products in the following chemical reaction, right? So you're going to underline, you're going to stop the video in a second, underline what you think are the reactants, and circle what you think are the products. So when you're ready to stop the video, stop the video. Okay, so I have underlined the what are the reactants, and I have circled what are the products and labeled them. And notice that I said that before this, that the reactants are going to be to the left of the yield arrow, and this is our yield arrow. So this is going to be the left-hand side of the equation, and then this is our right-hand side of the equation. So the reactants are always going to be the left-hand side of the arrow, and then the products are going to be to the right-hand side of the arrow. So basically the reactants point to the products. Okay, and don't forget what I said before too. If we have more than one reactant or more than one product, we got to separate them by a plus sign. Right? So hopefully you've got that and you understand that. If not, you should go back and review the video from before. The reactants are on the left side, separated by the products by the yield arrow, and the products are always on the right-hand side. Okay, for an equation to be valid and useful to the scientists, it must what we call be balanced. And there are as a technique for balancing equations, and the reason why we balance equations is the following, right? We cannot violate the law of conservation of mass. So we need to abide by the law of conservation of mass, which means that matter cannot be created or destroyed. Therefore, the number of moles of atoms of each element must be the same for reactants and products, and I'll show you what that means in a minute. And then finally, the number of atoms to balance an equation can be altered by placing a coefficient in front of the formula. In front of, not behind, not on top of, in front of. And here is one of the key things that you will have to make sure you understand when balancing. Never, ever, ever change a subscript. That will alter the chemical composition of that compound and therefore change the identity of the compound. Notice I'm circling this like 100 times. Never, ever alter the subscript of a compound. That will change the identity. So we will show you how these rules apply when we do this. Okay, so now we're going to show you, I'm going to tell you or teach you how to balance equations. So the first thing we always want to do is do an initial atom count for all elements on the reactants and product side, all right? And why you do that is to determine whether or not your equation is balanced, right? So if you have the same number of all the elements, same number of atoms for all the elements on both the reactant and product side, then the equation is probably balanced. If you don't, then the equation is not balanced. You're going to have to balance it. So the only way to balance the equation is you're going to have to add coefficients to some or all of the reactants and products, right? And when you do that, anytime you add a new coefficient in front of a compound, all the elements that make up that compound are affected by the new coefficient. So for example, if you put, if you're saying you're going to have sodium chloride, right? Sodium chloride on one side. So I'm putting sodium chloride here. And you have to put a 2 in front of that coefficient. You, not only do you have 2 sodium chloride, you have 2 sodium atoms now and 2 chlorine atoms, right? And then when you adjust all the elements in the formula, now you're going to have to do a new count. And here's some hints to help you do this. Save any free element. So if there's an element that stands by itself, so say copper or carbon or anything, zinc or whatever. As long as it's not bound to something else, it's called a free element. Save those until last to balance, because they're the easiest ones to balance. Because when you put a coefficient in front of them, there's no other element in that their quote compound to get affected, because they're the only one. If you have a polyatomic ion, right, polyatomic ion, those are the ones with 2 or more elements in them. And the polyatomic ion does not change as far as composition. In other words, if you have PO4 on one side and PO4 on the other side, treat it as a unit, and as a team, a unit, twosies or threesies. And the last thing is that you want to have the end coefficients. The end coefficients must be in the lowest whole number ratio, okay? And if you can do that, then you should be able to balance the equation. Okay, so let's look at some examples on the next page. Okay, so let's do 2 problems together, and then I'll let you loose on some other problems. So our first example is sodium fluoride decomposing to sodium metal and fluorine gas. All right, so the first thing we want to do is to see if it's balanced, right? And I already know it right now, it's not balanced, but let's just go through the exercise of why it isn't, all right? So I only have one reactant, and I have sodium and fluorine in it. So let's just do the atom count. 1 sodium atom so far, and then 1 fluorine atom so far. That's it. There's nothing else here, because there's no other reactant. And on this side, we have 1 sodium atom, so that's good. That checks out. So far in there, we don't have to worry about sodium. Oh, wait, I have 2 fluorine because I have a 2 here. So 2 times fluorine. All right. So our next step is now we're going to have to do a coefficient adjustment, right? Because otherwise, we're not going to be able to balance it. And the only way to get it balanced is because I have 2 fluorines here, I need to have 2 fluorines on this side. So the only way to get that, since I only have one compound, is to put a 2 in front of the sodium fluoride. Well, let's see what it does to our atom count now. So this is, remember, this was our reactants and products. Here's our reactants and products on this side. So now I have 2 sodiums on this side. And now I have 2 fluorines, so that's good. I didn't do anything to the product side, so I have the same things over there so far. It's 1 sodium and 2 fluorine. So while I fixed the fluorines to be balanced now, by adding this coefficient of 2, I've changed the number of sodium atoms on the reactant side. Where it was balanced before, now it's not balanced. So now the easiest way to fix this is to put a 2 here, because that will add 1 more sodium to the product side. And when we do that, we do change this to a 2. So our final content of this is to our final thing would be now 2 sodium fluorides yields 2 sodium metals and 1 mole of fluorine gas. Now let's look at the bottom one real quick. All right, so we're going to I'm just going to quickly go through this. So we have 1 times magnesium, right? And then we have the only other reactant on here is hydrogen chloride. So we have 1 hydrogen and 1 chlorine. Now let's go to the product side. I do have 1 magnesium here, so that's good so far. Ooh, wait, I have 2 chlorines and 2 hydrogens. So that's a 2 times hydrogen and 2 times chlorine. Wow, I have 2 elements that are out of balance, right? My magnesiums check, but the hydrogen and chlorines don't. And I have more of them on this side than I do this side. So I need to do in a postscript, I need to do a subscript, I need to do a coefficient adjustment on this side here. So let's do that. So the only place that has 2 that has hydrogen and chlorine in it is this molecule here, or this compound here, which is hydrogen chloride. And when I do that, now my new count, let's just going to put the blue ones right here, the new count. I still have 1 magnesium. I didn't do anything to that, but now I have 2 hydrogens and 2 chlorines. And I look on the other side, I have 1 magnesium, so that's a check. That's good. 2 hydrogens, that's a check. That's good. And 2 chlorines, and that's a check. That's good. So let's look at this equation real quick again. Our new balanced equation is just going to be that. It's just going to be, I'm going to make these a little bit bigger. 2 here, and that's it. That's the only thing I have to balance. Everything else is balanced now. So that's it. And this just confirms what I just showed you on the other page. This is the a more neat version of that. Okay, so I'm going to go to the bottom one of this first, and I'm going to tell you why I'm going to do that first. So this one is a little bit more complicated than the top one, and I'm going to save you. I want you to do the top one by yourself. And then on the next page, I will show you what the answers are to both. So let's just do the bottom one real quick. All right. So the bottom one contains lots of different types of elements, lots of different types of it has a polyatomic ion, and it has a lot of switching around. So let's just do what we normally do. So we've got to draw our line down the middle, and then we're going to do our initial atom count. So this is going to call this initial, because we're going to do a bunch of these initial. So we're going to do a bunch of these to do each one. So let's go to the first one. First one is iron. So we have 1 iron here. So 1 times iron. And then we have 2 times chlorine. And then we have 3 sodiums. So 3 times sodium. Okay. And we have 1 P, that's phosphorus, and 4 oxygen. 4 times oxygen. All right, so that's our initial count on this side. And our initial count on this side is we have 3 irons, right, because there's my 3 here. And then we have 1 chlorine. Then we have 1 sodium. And then we have we have a bunch of phosphorus, because we have 2 on the outside of the parentheses here, so that means everything in here is multiplied by 2. So we have 2 phosphorus and 8 oxygen. All right, so I just know, looking at this right now, I know it's not balanced. Everything looks like it's out of balance. There's not one thing that has the same number of atoms on each side. So what we're going to do next is now we're going to do just the coefficients, right? So I'm going to erase some of this real quick here, because we already know all this. All right. Okay, good. So let's adjust the coefficients. So my first thing to do is adjust the iron, because the iron contains a bunch of things. It's not a freestanding element. There's nothing freestanding here. So let's just adjust the iron. And the only way to do that, since I have 3 here, I need to put a 3 here. And now let's see what it does to here. So now my new count is 3 times iron. That's good. But now I have 6 chlorines because I have a 2 here and a 3, so that's 6 total. So 6 times chlorine. But I only have 1 chlorine here. But my iron's checked so far. So I should put a 6 in front of this to get my chlorines to balance. And if I do that, I have 6 chlorines here. That's a C. And then 3 times iron here. That's a chlorine. I'm going to do a better job of writing that. Chlorine. Okay? Now, but I have 6 sodiums here. Well, that's not good because I only have 3 sodiums over here. So in order for that to happen, I need to, since this is 3, I need to multiply this by 2. So let's do that. So now I have 6 times sodiums. Right, so that's checking, and that's checking now. And what did I do to my phosphorus? Well, since I multiplied this by 2, everything in this whole thing gets multiplied by 2. So now I have 2 phosphorus and 8 oxygen. So 2 times phosphorus, and since there's a 4 here, it's 2 times oxygen, which I have 4, so that's 8 times oxygen. And lo and behold, these now match. So now I have 2p over here, and 8 times oxygen over here. So everything checks. So all the atoms line up now. So this column here lines up with this here, and all these elements here line up here. So that's good. So our final equation is this equation right here. All right, 3 iron chlorides plus 2 moles of sodium phosphate yields 6 moles of sodium chloride and 1 mole of iron phosphate. All right, so that equation is now balanced and can be used in the next step. Okay, so here are the answers for both the other problems, and I just gave you the answer again for the bottom one, but you should check your answer against the top one because I asked you to do that on your own. Okay, you're going to look at this now and do these equations by yourself. And then when you're ready to come back to the video, you're going to hit the video start again. So when you're ready, hit pause and then come back to the video and I will give you the answers. Okay, so here are the answers from the problems that you should have tried on your own. Double check them. If you still are unsure of how to do these, you should come find me. But that's the end of the tutorial, and you should do some more practice problems and I'll have them ready for you in class.